Hello, and welcome to our Lightboard Talk. Today we're going to be talking about flow technologies. If you enjoy watching this video, don't forget to like it, and of course, follow the Kemp channel so you can get updates on future videos that we release. So flow technologies, what are they? And more importantly, why do they exist? Well, we need to go back in time a little bit. So we need to go back to Cisco, and we're going to talk about the 1990s. And in the 1990s, Cisco was looking for a way to make their routers more efficient. And they did this by looking at what the routers were doing with the packets as they were forwarding them on the network. So if we look at a packet, and here I'll draw a packet, the packet consists of a header and a payload. Traditionally, most of the volume of a packet is in the payload. But what the router cares about is in the header. And within the header, there are certain fields that it looks at to determine where to forward the packet in terms of the next hop in the path of the network. And what they determined was that we're looking at some certain fields. We're going to look at source IP, destination IP, source port, destination port, and IP protocol. So for example, if I'm looking at a packet and looking at the information that we see in the header of these fields, I might see something that I have a source IP of 10.10.1.101. That's my client. My destination IP is the server. And my server might be 192.168.100.201. My source port is going to be usually some sort of high port over 1024. So let's make up a port of 35712. And my destination port is going to be the application port. So if it's HTTP, for example, it would be port 80. Or if it's HTTPS, it'd be port 443. For Telnet, port 23, etc., etc. IP protocol is the type of IP traffic that it is. For TCP, this is going to be port 6. For UDP, this is going to be port 17. There are other protocols and ports to use. ICMP has its own port. Actually, OSPF protocol has its own port. So certain protocols that we use on the internet have different ports. But the most common ones that we talk about are TCP and UDP, port 6 and port 17. So I have these 5 pieces of information, and this 99.999% of the time designate a unique flow. In other words, if I see the same parameters in these 5 fields, it is associated with the same current connection between client and server. So this is what we call, since there are 5 fields, this is now what we call a 5-tuple. So we have this 5-tuple for the flow. And since we're collecting this information, we're also going to collect a few other bits of information. For example, we're going to collect the timestamps. So when did it start? When did it end? Therefore, how long did it last? We're going to look at the total number of bytes. So how much volume were sent? And the total packets. And by using these two, we can determine the average packet size. So there's lots of cool information. And that's what we determined with this flow technology. There's a lot of cool information, and if we store it and put it on a server and then collect information about it over time, we have lots of useful information. And we can track it. So we started creating flow collectors. These flow collectors collect the information that would be sent from the switches, the routers, the firewalls, the load balancers, other devices on the network that support this flow technology. In this case, for Cisco, this technology was called Netflow. And it is storing it and now displaying it in some fashion. We also have other technologies besides Netflow. After Netflow started becoming popular, of course, it was developed by Cisco proprietary, even though they opened it up to the world, but the internet world decided they wanted their own. So not only do we have Netflow, but we also have IPFIX. IPFIX is very similar to Netflow, but it's the true internet standard. It's the true IETF standard. And we have other technologies like JFlow, Juniper's version. We have SFlow, which is a custom sampling technology. So we have these other flow technologies that were created. But ultimately, it's the same concept in terms of the information we're collecting, sending to a flow collector. So now what can we do with all this data on the flow collector? And that's the awesome thing, because operationally, I can see who is talking to who, when, for how long, and does this meet my expectations of how I built the network and what people are doing and devices are doing on the network? For troubleshooting purposes, now I can say, is there a problem because I don't see a flow, or I do see flows that should or shouldn't be happening based upon these expectations? I can do trending analysis, so I can store this information over time. So I can say, okay, is this application growing in terms of usage? Are people coming from different places and doing things on my applications on my network? Do I need to change how I design my network to adapt to these changes based on this flow information that I'm collecting over time? Historical trending analysis. Another really cool thing that we can do is security. We know what is happening on the network. We know what should be happening on the network. What if we see things that shouldn't be? What if there's a worm or a virus? So if I have devices on my network, and typically this is what we should be seeing in terms of communications. One thing talking to multiple things. So this would be my server, and these are my hosts, my clients. Well, what happens when I start seeing traffic from client to client? And what does that mean? Does it mean that there's a virus that is now trying to infect other devices on my network? Is this expected? We can see not only this type traffic, but we can get details of what is being attacked, what ports are they trying to attack on the client. Maybe it's a remote desktop protocol, RDP. Or maybe it's FTP protocol, or maybe it's ident protocol, some of these old legacy protocols that aren't used anymore, but are possibly vulnerable and open. These flow technologies, through the flow collectors, and in terms of the analytics that these flow collectors can do on the data, can be astounding. So it is a really important tool for us in terms of network management, network planning, security, to be able to control and manage what's going on in our network. This is something that's becoming a lot more popular because we have this desire now to do things automatically and start getting visibility into the network, where previously we were so busy building them that we didn't have time to deal with this visibility. But now this is here. It's available. It's been around for a while, again, for 30 years plus, 20 years plus, and we have the capability to get so much data depending upon the intelligence and the heuristics of these flow collectors. So I strongly recommend that you look at flow technologies for your network. Chances are there are devices that you have that already support them. Of course, with Kemp Technologies, we support flow collector capabilities in our load balancers, and we also have our FlowMon product line that act as a flow collector and probes and collect all this information and give the heuristics. But in general, this technology is really cool. I recommend that you look at it, keep on doing more research, and see how you can implement it and take advantage of it in your network. So I hope you enjoyed today's video. Again, please like this video if you enjoyed it, and subscribe to the Kemp YouTube channel, and I look forward to seeing you in more Lightboard Talk videos. Thank you very much.